In this video, we have a very nice problem of combinatorics, that is, how many ways are there to arrange 6 girls and 15 boys in a circle such that there are at least 2 boys between any 2 adjacent girls. So I will solve this problem by 2 methods using 2 different concepts. So the first method 1 is, let's draw what is going on. So we have a circle and we have 6 girls and 15 boys. So first arrange these 6 girls. So 1, 2, 3, 4, 5 and 6. And now we have 15 boys, and there is a condition also, that is, there are at least 2 boys between any 2 adjacent girls. So what I am going to do is I am putting exactly 2 boys between 2 adjacent girls. 1, 2, 1, 2, 1, 2, 1, 2, 1 and 2, 1 and 2. Now the condition is satisfied and we have arranged total 12 boys. So we have 3 boys left. So we can arrange those 3 boys anywhere in the circle. 1, 2, 3. We can arrange it anywhere in the circle. Now we have to think about the number of ways we can make the arrangement like this. So what I am going to do is I am taking 1 girl and 2 adjacent boy and making them a group. So this is the first group, this is the second group, this is the third group, and it is the fourth group, and fifth group, and sixth group. So can I say that we have to arrange these 6 groups and these 3 boys in a circle. So here we have 6 girls, G1, G2, G3, G4, G5 and G6. And to make group for G1, we have to select 2 boys out of 15 boys. So we can select 2 boys out of 15 boys in 15 C2 ways, and these 2 boys can also be arranged in 2 factorial ways. And now for G2, we have only 13 boys left. We have already selected 2 boys out of 15 boys. So here we have 13 boys left, and we have to select 2 boys, and these 2 boys can also be arranged in 2 factorial ways. And now for G3, we have 11 boys left, and we have to select 2 boys, and 2 boys can also be arranged in 2 factorial ways. And similarly for G4, it will be 9C2 into 2 factorial, and for G5, it will be 7C2 into 2 factorial, and for G6, it will be 5C2 into 2 factorial. And now we have formed the 6 groups B G1b, B G2b, B G3b, B G4b, B G5b and B G6b. And we have also 3 extra boys, B, B, B. So we have total 9 objects. So we can arrange these 9 objects in a circle by 8 factorial ways, because the number of ways to arrange n objects in a circle is actually n minus 1 factorial, not n factorial. So here the total number of ways will be the number of ways we can form these 6 groups into the number of ways we can arrange these 6 groups and these 3 boys, that is 8 factorial. So it will be 15c2 into 2 factorial into 13c2 into 2 factorial into 11c2 into 2 factorial into 9c2 into 2 factorial into 7c2 into 2 factorial into 5c2 into 2 factorial and into 8 factorial. So we will get 15c2 will be 15 factorial by 2 factorial into 13 factorial, and we have 2 factorial into 13 factorial by 2 factorial into 11 factorial into 2 factorial into 11 factorial by 2 factorial into 9 factorial into 2 factorial into 9 factorial by 2 factorial into 7 factorial into 2 factorial into 7 factorial by 2 factorial into 5 factorial into 2 factorial into 5 factorial by 2 factorial into 3 factorial into 2 factorial and into 8 factorial. And now this 2 factorial and 2 factorial get cancelled, and similarly these 2 factorial, these 2 factorials and these 2 factorials, these 2 factorials and these 2 factorials get cancelled, and also these 13 factorial, these 11 factorials, these 9 factorials, these 7 factorials, these 5 factorials also get cancelled. So we get this 15 factorial into 8 factorial by 3 factorial. We get 15 factorial by 3 factorial into 8 factorial. It is the answer. And now the second method, method 2, is here we have a circle and we have 6 guns. So I am going to arrange these 6 guns in this circle: G1, G2, G3, G4, G5 and G6. So can I say that the number of ways to arrange these 6 guns in a circle is 5 factorial. Number of ways to arrange 6 guns in a circle is 5 factorial. And now we don't know the number of boys between these guns. So I am assuming n1 boys between G1 and G2 and n2 boys between G2 and G3, and similarly here n3 boys, here n4, here n5 and here n6 boys. So here can I say that n1 plus n2 plus n3 plus n4 plus n5 plus n6 is equal to 15, because we have total 15 boys, and there is a condition also, that is n1, n2, n3, n4, n5 and n6 all should be greater than or equal to 2. And now here n1 is greater than or equal to 2, so we can write n1 as 2 plus some n1 dash, and similarly n2 can be written as 2 plus n2 dash, n3 can be written as 2 plus n3 dash, and similarly n4 will be 2 plus n4 dash, and n5 will be 2 plus n5 dash, and n6 will be 2 plus n6 dash is equal to 15, and where n1 dash, n2 dash, n3 dash, n4 dash, n5 dash and n6 dash is greater than or equal to 0. So we get n1 dash plus n2 dash plus n3 dash plus n4 dash plus n5 dash plus n6 dash is equal to 3. And now here we can use beggar coin method. We have 3 coins that we have to distribute in 6 beggars. So it will be 3 plus 6 minus 1, C 6 minus 1. So we get 8C5, that is 8 factorial by 5 factorial into 3 factorial. So it is the number of ways we can make group of n1, n2, n3, n4, n5 and n6, and we have 15 boys. So those 15 boys can also be arranged in 15 factorial ways. Here 15 factorial is the number of ways to arrange 15 boys. It is the number of ways 15 boys to arrange. So the total number of ways will be here. Number of ways to arrange girls is 5 factorial, and number of ways to make group of boys is 8 factorial by 5 factorial into 3 factorial, and number of ways to arrange boys is 15 factorial. So here it will be 5 factorial into 8 factorial by 5 factorial into 3 factorial into 15 factorial. So this 5 factorial and 5 factorial will get cancelled, and we get 8 factorial by 3 factorial into 15 factorial. So